balloons will last over 100 days.
Done. Here we go, and we're awake. Ta-da! Don't put your fingers in there.
Yeah. What you're seeing is a balloon inside a balloon. We have a unique way of actually adjusting the altitude in these balloons.
This balloon has a constant volume, and there is helium in it, right? So the helium brings the balloon up. And now, if we want to change altitude, we have another balloon inside the balloon that we fill with air. And as we add more air in there, the mass is going to increase, and the balloon is going to go down.
Okay, this is called Hans, and we named it that because there was a Saturday Night Live skit, which was Hans and Franz, that's going to pump you up. And what it does is it's a little fan, and it pumps air into the balloon. It's easy to steer the balloon by picking up different winds and different wind directions at different altitudes.
By doing small change of altitude, you can do something like this. You go up, use this wind, then go down, use this wind, and go up, down, up, and down.
So this balloon has straps holding the apex up, and that balloon did not.
Right, which is why it's sitting down there.
Yeah, because yesterday when we were filling it up,
include this because this is what we used a lot to predict where we want to drive our balloon. And we've done really short flights because we haven't really done long flights yet because we want to recover the payload right now. But when we're doing longer flights, NOAA ARL, Air Resource Laboratory, the high split team has an amazing tool. It's actually called the balloon forecasting tool. I know a lot of people have used just the normal, high split trajectory model where you just run one trajectory.
This balloon is up at 60,000 feet, and that little white dot over there on the left is another balloon, 80 kilometers away. And if you look up at the top, you can see these little white things sort of appearing occasionally. That's because the balloon is slowly spinning around about 2 or 3 times per minute, and this platform is actually despun. It's constantly pointing at the other balloon. That's a contrail of a commercial jet at 30,000 feet, and we're up at 60,000 feet. So you see, this is also part of the free space optical communication. That's a little sort of a servo that keeps it pointed at that little balloon over there. And we were able to keep it a link of a gigabit per second over 80 kilometers for 10 hours. That's kind of the technology.
Not just our world better, but actually the whole universe.
That's exactly right. The essential idea of a balloon is to move an experiment over the atmosphere. Per square inch, there's something like 15 pounds of atmospheric weights on top of us.
Sometimes we have to make our spacecraft really small if we're trying to get them all the way up into orbit. But going up in a balloon, we can actually take a fair amount of weight. That's important because the more mass you have, that means the more instruments, the more science you can do.
Exactly right. So we can bring up to 8,000 pounds.
How big are these balloons and how long do they actually stay up?
We have a variety of balloons. The biggest ones are so big they fill a whole football stadium. Some of them last for hours and days, and the longest ones, the super pressure balloons, last for up to 100 days.
And one of the things I think it's important for people to understand is they actually rely on balloons every day in a way that they might not know about. Weather balloons launched every day help us to understand and predict tomorrow's weather.
NASA launches about 15 balloons a year from a variety of locations all the way from New Zealand to Texas.